Okay. Good morning to you all. We are studying hydrostatic pressure and its applications. Okay. We define the term pressure as the force acting per unit area. Okay. We define the term pressure as a force. It's a perpendicular force acting per unit area. Okay. Thereafter, we mentioned the unit for the pressure is Newton meter minus joule. Anyhow, as a tribute to scientist Pascal, we denote the SI unit for the pressure as Pascal. Okay, these are the facts. Thereafter, as solid objects exert pressure. Okay, as solid objects exert pressure, liquids also exert pressure. Okay, thereafter we have studied as solid objects exert pressure, liquids also exert pressure. Okay, in the liquid, pressure is exerted in by two ways. Okay, in the liquid, the pressure is exerted by two ways. That is first one due to the water column. Okay, due to the weight of the water column, and second one is the random movement of the particles. Okay, these random movement particles going to bump with the vessels or any objects present in the water. So by two ways water pressure will exert. Okay, thereafter we mention even force is a vector, pressure is a scale. Since pressure acts in all directions. Okay, pressure acts in all directions. Thereafter, we have studied the characteristic of hydrostatic pressure. Okay, hydrostatic pressure acts in every direction. First characteristic we have studied is the hydrostatic pressure acts in all direction, and second one is the hydrostatic pressure at the same level of liquid is same. Third one is the hydrostatic pressure increases with the increase in height. And fourth one is the hydrostatic pressure do not depend on the shape of the liquid column. These are the characteristic of hydrostatic pressure we have studied. Okay. Thereafter, we formulate a formula to find out the hydrostatic pressure. Here, hydrostatic pressure is equal to H rho G. That means H rho height for the water column, and rho is density of liquids, and G is gravitational acceleration. Okay. Thereafter, we have studied transmission of pressure through liquids. Okay. Thereafter, we have studied transmission of pressure through liquids. As per the fact that the liquids do not compress under normal condition. Okay. That's the important point. In the normal condition, we can't compress liquids due to the fact if the pressure exerts at any point in the liquid, then that can be transmitted to another point. Okay, due to the fact the liquids can't compress by external forces. So, if pressure exerted at one point, that can be transmitted to another points in the liquids. Okay. Thereafter, we have to study what are the applications of hydrostatic pressure transmission in day-to-day life. Okay. First one is the hydraulic press. Okay. First one is hydraulic press. In the hydraulic press, the principle of pressure transmission in the liquid is applied. Okay. Here, the hydraulic pressure, there are two pistons. One piston having smaller surface area and other piston having larger surface area. Okay. In the small surface area piston acts as a pump. Okay. This small area piston acts as a pump, and so it exerts a force in the liquids. Okay. These liquids exerted a pressure in the liquid. This pressure transmitted throughout the liquid as per the principle. Okay, principle, that is Pascal's law. That is, if a pressure exerted in one point of liquid, that can be transmitted throughout the entire liquids without loss. So this same pressure P will transmitted to the large piston. So this pressure exert a force in the larger piston. So this large piston going to move. This is the basic fact. Here the apply in here by the small piston we provide a small force, but this small force will be magnified. Okay, this is the basic principle. This also we have studied in last class. Okay. Second one is the hoist. Okay, the hoist also work under the principle of pressure transmission through liquids. Okay, hoist also works under the principle of pressure transmission through liquids. Okay, these hoists are used usually in motor vehicle stations. Okay, these hoists are used in motor vehicle stations to lift the vehicles. Okay, these hoists are used in motor vehicle stations to lift the vehicles. Okay, here also there are two pistons are available. These small piston, by small piston we give a small force. Okay, smaller force, when apply smaller force in small piston, this force exert a pressure in the liquid, that is oil. Okay, that is oil. This force exert a pressure in the oil. Okay, as per the principle, this pressure transmitted to this point, that is in the larger surface area pistons. So this pressure exert a force on the large surface area pistons. Okay, this is the basic principle. When the force exerted by the liquid, that is the force exerted by liquid greater than the weight of, we know the weight of the vehicle is mg. Okay, if the force exerted by the liquid greater than weight of the vehicle, the vehicle will be lifted. Okay, this vehicle will be lifted. This is the basic principle of thrust. Okay, third one is the hydraulic jack. Okay, that is hydraulic jack. Okay, this also works under the principle of pressure transmission. Okay, this also works under the principle of pressure transmission. Actually, it is used to lift one side of the vehicle. Okay, actually it is used to uplift or lift one side of liquids when the wheel of the vehicle. Okay, if we need to detach the wheel, we have to uplift one part of the vehicle. No, so if we need one part, if we need to detach the wheel of the vehicle, we have to uplift one part of the vehicle. So due to this scenario, we use the hydraulic jack. Okay, this hydraulic jack also works under the principle of pressure transmission. Okay, here there is a small piston and also a large piston. If we apply a small force in the small piston, this force exerts a pressure in the liquids present in these hydraulic jets. Okay, by these liquids there is a larger force. This pressure is transmitted through the liquids and there is a larger force will exert in the large piston. This is the basic principle of hydraulic jet. Okay. Fourth instance, where principle of liquid pressure transmission is applied is hydraulic brake system. Okay, fourth instance is the hydraulic brake system. First one we have studied hydraulic press. Second one is we have studied the hoist. Third one is hydraulic jack. And fourth one we are going to study is the hydraulic brake system. In those four scenarios, the principle of principle of pressure transmission through liquid is applied. Okay, in all the scenarios, the principle of pressure transmission through liquid is applied. Okay, now we move to the how the hydraulic brake system applied. Okay, here in the brake system, when the driver applies a force on the brake pedal, this is the brake pedal. Okay, this is the brake pedal. When the driver applies a force, uh, here the driver is applies a force on the brake pedal. Okay, by this brake pedal, this force will be transmitted to the master cylinder. That is the piston present in the master cylinder. There is two cylinders present. Those are, first one is master cylinder, second one is slave cylinder. In both cylinders, there is two pistons are available. Actually, in the master cylinder, the surface area of the piston is smaller than the piston that is present in the slave cylinder. Okay, that is the basic structure of brake system. Okay, when the driver applies a force on the brake pedal, this force will be transmitted through this pedal to master cylinder piston, that is pistons present in the master cylinder. Okay, so this force exerted pressure in the fluid. Okay, due to the force applied by the driver, there is a pressure will be exerted in the fluid present in the master cylinder. Okay, thereafter the brake fluid, this pressure will be transmitted to the pistons that is present in the slave cylinder. Okay, that is present in the slave cylinder. Now, uh, now the brake pads. This pressure goes to press the brake pads. So the brake discs move and compress. Okay, it caused brake pads to press to apply a pressure on the brake disc. Okay, this is the basic principle. Okay, for the instance, where principle of liquid pressure transmission is applied is hydraulic brake system. Here, uh, when the driver applies a force on the brake pedal, it is transmitted to the piston in the master cylinder. Okay, this force will be transmitted to the piston present in the master cylinder. So it exerts a pressure to the fluid in the cylinder. That is oil. No, the pressure will be exerted on the oil that is present in the cylinder. Thereafter, as per the principle of pressure transmission, this pressure will be transmitted to the piston present in the slave cylinder. Okay. Thereafter, it caused brake pads to press to apply a pressure on the brake disc. Okay, brake disc. So the brake disc. That is the way the hydraulic brake system works. Okay. Now we have studied the solid pressure. We already studied. Thereafter, we have studied hydraulic pressure and its applications. Okay. Now we are going to move to pressure due to gases. Okay. As solid and liquid. Okay. As solid and liquid, gases also exert a pressure. Okay. As solid exert pressure, as liquid exert pressure, gases also exert pressure. There are two ways in which pressure can be produced by gases. Okay, there are two ways. One is the due to the weight of the column of gas. Okay, one way the pressure is exerted by the gas is due to the weight. Okay, weight of the gas. We know gases also have weight. So, due to the weight of the gas, there will be a pressure will be exerted. And second one is when compressed air, the compressed gas atom to expand, it will create a pressure. Okay, there are two ways the pressure will be exerted by gases. First one is due to the weight of column of gas, and second one is due to the when compressed gas attempt to expand, there will be a pressure will be exerted. Okay, these are the basic principle of pressure due to gases. Okay, next we move to activity. Okay, the aim of this activity to find out that compressed compressed air attempt to expand, there will be a pressure will be created. That's the aim. Okay, that's what's the aim of our activities, to find out that when compressed gas attempt to expand, pressure is created. That is the our aim of the activity. To do this activity, we have to take a dew tubes. Okay, we have to take a dew tube and pour water into the dew tubes until the water level in the both arms are become equal. Okay, we have to pour the water into the dew tube until the water level become equal in both arms. Okay. Thereafter, we have to take a balloon and we have to fill the balloon with air. Thereafter, we have to tie this air-filled balloon in the arm of X. Okay. Now, we are going to observe what will happen. Okay. Now, we can observe that the water level in the arm goes down. Okay. Water level in the arms goes down, and water level, this is the initial water level. Okay. Now the water level in the arm become low, goes down, and the water level in the arm by goes up. Okay. Are you clear? What's the activity we have to do? We have to take a dew tube and we have to fill the dew tube until the both arm water level in the both arms become equal. Okay, until the water level in the both arms become equal, we have to pour the water. Thereafter, we have to fill the balloon and tie the filled balloon in the arm X. Now, we are going to observe what will happen. Okay, we can observe that the water level goes down in the arm X. Okay, in the arm X, water level goes down, and in the arm Y, water level goes up. That is our observation. Okay, from this observation, we can conclude that pressure will be created when compressed gas attempt to expand. Okay, we can confirm that compressed gas exert a pressure when it attempt to expand. Okay, this is our conclusion. Now, uh, if we see the dew tubes, there is a water level are equal. That means we know at the surface area of water, at the point of these 2 points, the actual pressure is the atmospheric pressure. And also we know the water pressure in the same level of liquid is same. So in the first A, in the A picture A, the water level is same. So we can say the pressure at both points is equal. That is atmospheric pressure. Due to the fact the water level in the dew tube is same. That is the first scenario. I clear? In the first scenario, in the dew tubes, we can observe that the water level is same. Why this water level is same? We already studied that the water pressure at the same level of liquid is same. We already know the pressure at the surface of the liquid is atmospheric pressure. There is no water column here now. So, the pressure at these 2 points is actually atmospheric pressure. That pressure will be created by the atmosphere. Okay. When we during this second picture, we are going to fill large amount of air inside a limited volume of balloon. Okay. When we filling the balloon with air, what we are doing? We are doing large amount of air limited into the balloon. Okay. So we fill large amount of volume of air fill in the balloons. Okay, this is the second scenario. Thereafter, we can observe what will happen. We know the pressure at this point is atmospheric pressure. Okay, we already studied the equation for the hydraulic pressure at the point of here. Here is the P plus H rho D, that is the height of the water column is H, given as height of the water column is given as H, and rho is the density of water. So, in these points, the pressure is equal to P plus H rho D. That is, P means that is atmospheric pressure. P is atmospheric pressure plus height into density of liquid into gravitational acceleration. Okay. Now we can confirm these points. In these points, the pressure is higher than these points. Okay. That is Y point. The pressure in X point is greater than the pressure of Y points. How this pressure will increase? Okay. So we can confirm that this compressed air going to expand. So this compressed air attempt to expand, it exerted pressure. Due to this pressure, the pressure in the surface area of X will increase by H rho U, rho G. I clear? This is the discussion of our activity. Okay. Our activity is to find out that compressed air, when it's going to expand, it creates a pressure. That is the aim we have to confirm. Okay. To do this, we have to take a tubes and fill the tube with water, and we have to tie an air-filled balloon with one arm. And if we observe what will happen, we can observe that the pressure, water level in the X will goes down and the water level in the Y goes up. Due to the fact, we can confirm that when compressed gas attempt to expand, it creates a pressure. Okay, these are the facts. Okay, now we move to the atmospheric pressure. We move to the atmospheric pressure. Actually, Earth's atmosphere extends hundreds of kilometers above the surface of Earth. Okay, Earth atmosphere. This is the Earth atmosphere that extends hundreds of kilometers above the Earth. Okay, above the Earth, there's a hundred of kilometers. This Earth atmosphere is expanded. Okay. Similar to the pressure produced by the liquid, okay? We already studied that the pressure is created by due to the weight of the liquids. So, similar to the pressure produced by the liquid, pressure is created by this atmosphere on the earth, okay? This is known as atmospheric pressure, okay? Similar to the pressure produced by the liquid due to its weight. Okay, pressure will be exerted at any point of atmosphere. Okay, similar to the liquid, at any point of the atmosphere, pressure will be exerted due to the weight of air column. Okay, this is the air column. We know this air column has some weight. Okay, due to this weight of air column, in all the atmosphere, there will be a atmospheric pressure will be generated. Okay, there will be atmospheric pressure will be exerted. Now we move to the barometer. Actually, barometer is an instrument that is used to measure the atmospheric pressure. Okay, barometer is an instrument that is used to measure the atmospheric pressure. There are two types of barometers are used mostly. First one is mercury barometer. Second one is aneroid barometer. Okay. Actually, the first barometer, that's atmospheric pressure, was measured for the first time by Italian scientist who is Torricelli. Okay, this mercury parameter was demonstrated by the scientist Torricelli. Okay. Now we move to the mercury barometer. Okay, structure of the mercury barometer. Actually, this instrument can be made by a glass tube about 1 meter long. Okay, we have for making this mercury barometer, we have to take a 1 meter glass rod, glass tube, okay, with one closed end, okay. This this glass tube have to have one closed end and one open end. This is open end, this is open end, and this one is closed end, okay. So first we have to take a 1 meter long glass tube. Thereafter, we have to fill this tube with mercury. Okay, the tube have to fill with mercury and it have to turn upside down. Okay, we have to confirm that during when we observe turning this tube as upside down, we have to sure that no air enters to the tube. Okay, there is no air. It is a vacuum. So we have to confirm that no air enters into the glass tube. Okay, then we have to immerse this tube into the container of mercury. Okay, we have to immerse this tube into the container of mercury. Now we can observe the height of the mercury column left inside the tube is about 76 centimeter or 760 millimeter. Okay, this is the basic structure of mercury barometer. Okay, mercury barometer, actually these instruments, to making these instruments, first we have to take a 1 meter long glass tube. Okay, thereafter we have to fill this glass tube with mercury. Thereafter we have to turn this tube as upside down. Okay, as upside down. During this procedure, we have to confirm that no airs enter into the tubes. So, there is no air in the vacuum. This is a vacuum. There is no air present in the glass tubes. Thereafter, we have to immerse this 1 meter glass tube into the container that contain mercury, some mercury. Okay, so now we can observe that mercury that's left. We fill this glass tube with mercury, but after we can observe the mercury that is left in the glass tube is about 76 centimeter. Okay, the mercury that left in the glass tube is about 76 centimeter. Okay. Now, as we already formulate a formula that is for the measurement of the hydraulic pressure, that is pressure is equal to H rho D. So, as our already studied knowledge, we can find the pressure at this surface of the mercury. Okay, we can find the pressure. How? We already know the formula is equal to P is equal to H rho D. We have studied. Okay. This is vacuum, so there is no pressure in the vacuum. So the pressure at this point, that is the surface or area of the mercury, we can say the pressure is equal to H rho D. H means that is the height of the liquid column. How much here height of the liquid column? That is 760 millimeter. So it is a 0.76 meter. Okay, it's a 0.76 meter, and the density of the mercury is given as 13,600. Okay, 13,600 into gravitational acceleration given is 9.8. Okay, so answer will become as 1.013 into 10 to the power 5 Newton meter minus 2. Okay. Okay. No. Now we find out the pressure at the surface area or bottom of the tube. Okay, bottom of the tube we find out the pressure. So we find out the pressure as our already studied formula, that is pressure H is equal to H into rho into G. Okay, H is 76 centimeters, so rho is given 13,600. That is the rho, that is the density of mercury, and G is given as 9.8. So, if we substitute this value in the formula, we will get the answer 1.013 into 10 to the power 5 Newton meter minus 2. Okay. So, that is the standard pressure or 1 atmosphere. That is pressure at the bottom of the column of mercury. Okay, pressure at the bottom of column of mercury that have the height of 760 millimeter. Okay, pressure at the bottom of the tube that have the mercury of 760 millimeter height. For a particular mercury, the value is D. We said it has a standard pressure. Okay, that is the standard pressure. The standard pressure means the pressure generated by 76 centimeter height mercury column. Okay, by the 76 centimeter mercury column, how much pressure will be generated is we called it as standard pressure or 1 atmosphere. Okay, that is we called as 1 atmosphere. Okay, so 1 atmosphere is equal to, so we can say it as 1 atmosphere is equal to 76 centimeter mercury. Okay, 76 centimeter mercury, or we can say it as 1.013 into 10 to the power 5 Newton meter minus 2. Okay. 1 atmospheric pressure means that is the pressure generated by 76 centimeter length mercury column. Okay, so we can say 1 atmosphere is equal to 76 centimeter mercury, or that is 1.013 into 10 to the power 5 Newton meter minus 2. Okay, are you clear? This is the basic structure of mercury barometer. Okay, now there's a questions. You can sorry, the atmospheric pressure at sea level is given as 76 centimeter mercury. Okay, there's a fact that was given that see atmospheric pressure at the sea level is 76 centimeter mercury. Taking the density of mercury as 13,600 kilogram meter minus 3. Acceleration is given as 10 meter second minus 2. The question is, find out the height of the water column that can be balanced by atmospheric pressure. Okay, this barometer, instead of mercury, we can use water also. Okay, now first scenario. Okay, first scenario, a barometer that is used mercury. Okay, mercury. When using mercury, the atmospheric pressure at sea level is 76. Okay, atmospheric pressure is 76 centimeter mercury. Okay, now here we used mercury. Okay, now we can use water instead of mercury also. So if we use in this barometer, we are going to choose the water. So the question is, what is the height of water column? That is the question. Okay, that is, you know the pressure, the atmospheric pressure is equal in the bottom of the glass tube. Okay, bottom of the glass tube is equal to atmospheric pressure. So if we write a formula for the first scenario, P is equal to P is equal to H rho D. Okay, H into rho D. H is given as 76 centimeter mercury and rho is given as 13,600. 13,600 into 10. Okay. Likewise, pressure at this point. If we use the water as the fluid in the mercury water barometer, the pressure also same. So here, if we apply our formula, that is P is equal to H rho D. H is we have to find. Okay, H is we have to find. The question is how much of water column. Okay, the density of water is 1000. It's also given. Okay, density of water is 1000. Okay, 1000. D is 10. Okay, we know these both P is equal. That is the atmospheric pressure. That is the atmospheric pressure. Here we can notice this point. Only the atmospheric pressure is available. To find out this atmospheric pressure, we already know the pressure at the same level of liquid is same. Okay, we already studied in this point the surface of the mercury. There is the atmospheric pressure exerted. Okay, we already studied the pressure at the same level of liquid is same. So throughout this level, the pressure is same. Are you clear? Throughout this level, pressure is same. Okay. When we look this point there is no atmospheric pressure is applied. Only the hydrostatic pressure due to the column of water. Okay. So this is we have already studied that this pressure exerted by the liquid is H rho D. Okay, H rho D. So we can say P atmospheric pressure is equal to H rho D. Are you clear? So in both scenarios, atmospheric pressure is same. So we can write it as H into 1000 into 10 is equal to 76 centimeter mercury into 13,600 into 6. Okay. If we simplify this, we can get the answer of H is equal to 10,336 meter. Okay. When we use the mercury, we get the height of only, centimeter. We get the height of only, meter. This meter. Okay. Meter. So now we see when we use the mercury as a liquid in the barometer, we need only the tube of 1 meter enough because 76 centimeter means that is 0.76 meter or 4. But if we use the water, we have to need 10.336 meter. Okay. Due to these facts, we are using mercury as a fluid in barometer. Are you clear? Why we use the mercury as a fluid in barometer? If we use the water as a fluid of barometer, we have to need a 10-meter long glass tube. But if we used mercury, we only want 1 meter length glass tube. Are you clear? Due to this fact, we are using mercury as a mercury fluid in mercury barometer. Okay. Then second one is the aneroid barometer. Okay, first barometer we have studied is the mercury barometer. Second one is aneroid barometer. Okay, in the aneroid barometer, it has a cavity. Okay, this is the cavity. This one is the cavity. It has a cavity that is bounded by a thin metallic core. This is the thin metallic core. Okay. This is a thin metallic core. Okay, the aneroid barometer. There is a cavity. This is the cavity that is bounded by a thin metallic core. Okay, when the pressure outside barometer varies. Okay, this is the atmospheric pressure. When the pressure in the outside of this cavity varies, the shape of the cavity also varies. Okay, the shape of the cavity also varies. So, an indicator, okay, this is the indicator that attached to the cavity wall rotates. Due to this variation of this shape, this indicator that is attached to the cavity is going to rotate with variation of the shape of the ball. Okay, this is the basic principle of aneroid barometer. In the aneroid barometer, there will be a cavity. This cavity is bounded by the thin metallic core. Okay, according to the variation of the atmospheric pressure, this shape of the thin metallic cores also varies. Okay, as variation of this shape, this indicator going to rotate. So there will be a pressure can be measured. Okay, these are the two methods using to measure the atmospheric pressure. Okay, first one is mercury barometer. Second one is the aneroid barometer. Okay. Now we move to how atmospheric pressure changes with altitude. Okay, with the increasing altitude, you can observe with the increasing altitude at the point of 2000, their atmospheric pressure is approximately 60. When increasing the altitude, at the point of 10,000, the atmospheric pressure will reduce to 35. Okay. So atmospheric pressure decreases. Atmospheric pressure going to decrease with the increasing altitude. Why this atmospheric pressure decreases with the increasing altitude? When the altitude is increases, the weight of the column of air will reduces. Okay, we know when moving to the high altitude, the weight of the air column will reduce. At this point, the only height is this one. But in here, lower altitude, the whole the air column will exert pressure. Okay. So, in the lower altitude, there will be a higher pressure, and when increasing the altitude, the high atmospheric pressure will reduce. Okay, the atmospheric pressure decreases with the increasing altitude. Okay, now we move to the application of atmospheric pressure in daily life. Okay, in what scenarios, what sequences we use the atmospheric pressure. First one, ringing with the use of straw. Okay, this we are usually use the liquid substances by using liquids. Okay, when we drink the water or liquid particles by straw, we suck the air inside the straw by the mouth. Okay, we suck the air inside the straw. So the pressure inside the straw will reduces. Okay, but the pressure at the liquid surface, here is atmospheric pressure. If we see at this point, the pressure will atmospheric pressure plus H rho G due to the column of water. So there will be a higher pressure outside the straw and lower pressure inside the straw. So the atmospheric pressure push liquids in the glass into the straw. I clear? When we suck the air present in the straw, there will be a pressure will be reduced in the straw. Okay? When we suck the air in the straw, the pressure will reduce into the straw. But the outside of the straw, there's a higher pressure. So the liquids going to move from the higher pressure to the lower pressure. Okay, that is the first scenario. We use the atmospheric pressure in daily life, that is ringing with the juice of straw. Okay. Second one is the removing of the water in the tank using siphon method. Okay. Uh, if we assume this point as A and this is the point B. Okay. Uh, at the point A, pressure is equal to atmospheric pressure, pressure due to atmosphere, plus pressure due to this hydraulic column. So, at the point of A, pressure is equal to P, that is atmospheric pressure, plus H rho D, that is pressure due to the water column. Okay. Likewise, at this point, in the surface of these points, the pressure is atmospheric pressure. So, at the point of A, there will be a higher pressure, and the point of B, there's a lower pressure. So, water going to move from the higher pressure to the lower pressure. That is the second application of the atmospheric pressure. And third one is the action of rubber sucker. Okay, the third one is the action of rubber sucker. When a rubber sucker, okay, when a rubber sucker is pressed onto the glass surface, okay, so if it's pressed on a glass surface, most of the air between these two surfaces is removed, okay. So there will be a vacuum is created. Here, vacuum will be created. So, the pressure inside the vacuum is lower than the outside of this sucker. So, this atmospheric pressure held pressed on the surface. Okay, this atmospheric pressure held pressed onto the surface. This is the third application of the atmospheric pressure. Okay, now we studied the applications of the pressure. Atmospheric pressure. First one is the ringing with the use of water. Second one is removing of water in a tank using siphon method. And third one is action of rubber sucker. Okay. Okay. Let's summarize what we have studied today. We have studied the pressure due to the gases. Okay, now today we have studied how the pressure is created by the gases. As the liquid, the weight of the gas column create a pressure. First method, the pressure exerted by gases is due to the weight of gas column. Second one is when a compressed gas attempt to expand, it create a pressure. That is the second scenarios. Okay, by two ways the pressure is exerted by gases. First one is due to the weight of gas column. Second one is when compressed gas attempt to expand, it will create a pressure. Then we carry the activity to find out whether compressed gas attempt to expand, pressure is created or not. Okay. So to do this activity, we taken a dew tube and pour these dew tubes with water until both water level at the both arms become equal. Thereafter, we tie a air-filled balloon with the arm, okay, with one arm and observe what will happen. Okay, we can observe the water level goes down at the arm of X. That is here the balloon was tied. Okay, the arm that is here the balloon is tied. The water level going to goes down. But in the another arm, water level goes up. Okay. Due to this observation, we can confirm that the pressure will be exerted during compressed gas attempt to expand. Okay. First, we have carried a discussion why this observation occurs. When we pour water in the dew tubes, the pressure level at both arms equal because Pressure at all points on the same level of liquid is same. We have already studied. So, if we pour the water in the tubes, in both arms, pressure water level will be equal. Thereafter, when we tie a balloon with one arm, there will be a pressure exerted by this balloon. Therefore, the water level in the arms goes down. Okay, due to this goes down, the pressure at the point of X will increase by H rho d. So we can say the pressure at the arm will increases by H rho d. That is the increased pressure. Okay, so this increased pressure is exerted by this compressed air in the balloon. We can confirm that increased pressure of H rho d is created by the compressed air in the balloon. Okay, these are the facts we have studied. Then we move to the atmospheric pressure. Atmosphere in the earth, up to hundreds of meters, atmosphere is extended. Okay, so in the earth, from the earth's surface, there is up to 100 meters, atmosphere is extended. Atmosphere with gases has weight. Okay, as water column, the pressure weight due to the weight of water column, pressure exerted. Due to the weight of atmospheric gases, there will be a pressure exerted at any point of atmosphere. Okay, there will be a pressure is exerted at any point of the atmosphere. So thereafter we study the barometer. Okay, barometer is an instrument used to measure the atmospheric pressure. Okay, this instrument was first introduced by the Italian scientist Torricelli. Okay, in day-to-day life we use two main types of barometers. First one is mercury barometer. Second one is the aneroid barometers. Okay, for making mercury barometer, we have to take 1 meter length glass tube and fill with mercury. Thereafter, we have to turn this tube as upside down. We have to confirm that no air is entered into this tube. Okay, we have to confirm. So here we come no air. So it is there will be a vacuum created. Okay. Thereafter, we have to immerse this glass tube into the container that also having mercury. So now we can observe the height of the mercury column left inside the tube is approximately 76 centimeter. Okay, 76 centimeter. Thereafter, we have calculate the pressure, atmospheric pressure. Okay, we already studied the hydraulic equation for the hydraulic pressure is H rho d. Okay, so we use here. This is a vacuum, so the pressure at the bottom of the tube is H rho d. Okay, H rho d. We already studied the pressure at the same level of liquid is same. So in this point only the atmospheric pressure is applied. In this point only the pressure due to the mercury column. So both are in same level. So we can say the pressure generated through by this mercury column is equal to atmospheric pressure. Are clear? Pressure generated by the mercury column is equal to atmospheric pressure. So we carried activities and we find out the atmospheric pressure as 1.013 into 10 to the power 5. That is Newton meter minus 2. Okay. So we say it as a standard pressure. What is standard pressure? Or 1 atmosphere means if length of the mercury column is 76 centimeter, we say it as standard pressure. Okay. What is standard pressure means that is 1 atmospheric pressure or that is equal to 76 centimeter mercury or 1.013 into 10 to the power 5 Newton meter minus 2. Okay. These are the calculation we have carried. Thereafter we have studied why we use mercury instead of water as a fluid in barometer. Okay, if we take water as a fluid in barometer, we have to take more than 10-meter length tube. But we use mercury as a fluid. We only 0.76 meter or 1 meter is enough for us. Due to this fact, we taken mercury as our barometer fluid. Okay. Thereafter, we have studied how the atmospheric pressure changes with altitude. Okay, with increasing altitude, atmospheric pressure will reduce due to the fact that the reducing the air column. Okay, due to the fact that the air column going to reduce, so the pressure also going to reduce. Then the other barometer, that is aneroid barometer. Aneroid barometer actually have a cavity that is covered by a thin metallic wall. Okay, due to the variation in the atmospheric pressure, the shape of the metallic wall will change. These changes, according to these changes, this indicator going to rotate. So we can get the reading from this aneroid meter. These are Thereafter, we have studied what are the applications of atmospheric pressure in daily life. Okay, first one we have studied ringing with the juice of straw, and second one we have studied the removing the water in the tank, and third one we have studied the action of rubber sucker. Okay, these are the facts we have studied. In next class, we are going to study Archimedes principles and upthrust. Okay, thank you so much.